So quick Vista by the numbers. For those of you who don't know us, we've been around selling and technology and supporting it for more than 30 years. We shipped more than 25,000 orders last year, and we have a lot of customers across a lot of continents. And these customers are anyone from, let's say, your traditional small business with maybe as few as 100 end users and a couple dozen servers, all the way up into the Fortune 1000 and Fortune 500 organizations. So we see a lot of different use cases. We got a lot of different customers. So come see us with any technology issues you have. Frank, next slide. Core competencies, data center. So when we look at scale computing, that falls squarely into our data center competencies. It's hardware, software, services around those products. We also do some pretty cool things with supply chain. We buy back existing hardware. We have inventory. We can ship stuff to just about any country out there that you'd like. And lastly, technology services. So not only implementation services, but we also have ongoing monitoring, management, and maintenance of your infrastructure. So again, let us know where we can help. And that is it for me. So again, questions in the question box. Fill out that survey. We'd really appreciate it. And with that, I will hand it off to Frank.
All right. Thank you very much, Rob. Quick audio check. You can hear me all right? Make sure I unmuted myself.
Certainly can.
Yep. All right. Good. Thank you. Thank you. So, yeah, as Rob mentioned, my name's Frank Seal. I'm one of the senior systems engineers here at Scale Computing. Talk a little bit about hyperconvergence or HCI. There's different acronyms, buzzwords around that. But to jump in, I want to talk a little bit about who Scale Computing is. We've been one of the first products out there doing the hyperconvergence. We started shipping product back in 2012. We're headquartered right in Indianapolis, Indiana. We do have an R&D office out on the West Coast in San Francisco, and we have sales offices across different areas across the globe there. More than 3,000 clusters in production environments out there, 10,000 total systems running. Our ongoing support, the help desk, that's based at our headquarters here in Indianapolis, Indiana. One of the reasons why we have that high NPS score. You know, the people that are existing customers rate us very high, not only because of the quality of the system, but the ongoing support around that as well. This right here is showing the trends that many of the analysts are showing with infrastructure and the growth throughout the years. You're starting to see the days where hyperconvergence or HCI is now exceeding the sales of just traditional infrastructures. That's your servers, your SANs, those type of deployments here. HCI has far exceeded those traditional sales now. And one of the highest rating parts, or one of the highest selling parts of that, is KVM-based or VMware alternatives. That's one of the fastest growing subsets within that, which is what we fall on, what we started with from day one. And we could go, I'll go into that a little bit more about how we kind of displace some of those existing licensing models to bring that ROI down or bring it in a lot quicker. Now, I've mentioned HCI, hyperconvergence a few times. For those that might not keep up with all the technology buzzwords, I like to throw this definition out here. To us, it has a specific meaning. So what we wanted to do was to take servers, storage, and the hypervisor, that's the hyper part of hyperconvergence, and bring it all together into an appliance model there, to where now I'm thinking of my infrastructure as Lego blocks versus all these different moving components that I have to manage, I have to procure, and radically simplifies that entire infrastructure there. So if you looked at what people have been doing since probably the late 90s here, is when I wanted a highly available virtual solution, I would go out and model something like this. I would go out and buy me a SAN of some kind, different vendors, tons of vendors out there in that storage market there. And then I would network across to some host servers, license the proper amount of VMware, which edition do I want, depending on the features. And then once I've got that configured, now I start carving up disk sets, creating LUNs, data stores. I've got to multi-path those across some switches, and now VMware sees it and says, hey, we'll put our own file system on there. And then what do? I carve those up smaller for my individual virtual machines. Now, we looked at this and said there's got to be a better way to do this. There's too many points of failure within here. There's too many vendors at play. When I want to have any type of troubleshooting, who am I going to call? Am I going to call Dell for my server hardware, or VMware, or maybe NetApp for my SAN side? A lot of finger pointing in these type of solutions. They weren't built with each other in mind there. A lot of inefficiencies here. I mean, there's a file system on a logical disk that sits on yet another file system on another logical disk. One more logical disk, yet another file system, finally down to some disk. You're looking at about 11 hops for the data to pass through before it resides down to that disk. We wanted to streamline this, and we said, what if you ran the virtual machines right on top of the storage layer itself? Let's eliminate a lot of those bus stops along the path here. And then by doing that, we're also going to mirror and stripe that data across multiple disks, multiple nodes to create that high availability that I want. But now, with our unique storage layer, we can get through and create a highly available write in 3 jumps versus the 11 of that traditional SAN that you see there. This eliminates all that vendor intercommingling there. It's very efficient to set up and troubleshoot and manage because it's all one system to me here. We're not the only product out there that's touting hyperconvergence. There's many others. But if you look into the architecture of what other vendors out there are doing, they do what's called a VSA model, or a virtual storage appliance. And what that really boils down to is, instead of eliminating the SAN like we do, they just virtualize the SAN. They create a large controller VM that runs on each one of my host servers that is taking away resources that I could use for my virtual machines. So we end up having to buy bigger, badder, more performance in tuned hardware to accommodate that unwanted workload of their virtual storage array here. The data path is exploited greatly by having to do multiple hops within there. So efficiency isn't necessarily a key takeaway on many of the other items. With us and that efficient storage stack, this allows us to get into a lot smaller hardware platforms, whether it is some of our smallest gear that's about half-depth servers, or even something as small as an Intel NUC for retail locations. We've got many different platforms we can fit on that other vendors have no way of squeezing and getting onto that hardware. Every product that we make has these 4 pillars available to it. We wanted that simplicity there. I want to manage the infrastructure like it's one big cohesive piece. I don't want to be a SAN administrator for a few hours, jump on, do some hardware management, then jump into my VMware interface and do things with that. Storage, again, I didn't want to have to read a 12-page white document to figure out how I should best carve up my storage array. Deployment of the system, the first time you do this, it's honestly about as easy as putting a printer on the network. Very quick and easy deployment time. So if it's one of those repetitive processes where, hey, maybe I have 300 retail locations and I've got to get these out now quick, it becomes very streamlined there. We've baked in a lot of intelligence within the product, self-healing, that's always constantly evolving. I can survive multiple hardware issues all at the same time, and my workload can continue to operate. There's built-in replication, so if I want to distribute my data, my workloads to multiple locations, I can do that. It doesn't require any third-party tools or additional licensing. That scalability aspect, think of them as Legos. Stack on as many as you need to get those resources that you want. Any of our gear within any of our families can all be mixed and matched. There is no hardware compatibility list. So now, as the person on the IT side, I just think about the resources. I don't think about, did I paint myself in a corner by going with this vendor in this particular product line. And that all leads down to that affordability. Since it is that single stack there, I don't have multiple contracts. I don't have different end of lives I'm chasing after. I'm bringing my licensing costs down, and it creates that overall lower cost of ownership there. Ways to help with backup and disaster recovery, again, baked right within the product. There's built-in snapshotting, which I'll show here in a little bit when I'm doing the demo there, that I can instantly spin up other instances of virtual machines right within the product there, create those virtual sandbox that I need to. I can take those snapshots and I can ship them off at other locations, maybe locally to another single node that I have. Maybe I want them to be exported out to a NAS device that I have sitting around. That can easily be done, and it's all within the product itself. Again, no third-party tools need to make that happen. Maybe I want a more robust disaster recovery scenario. I can replicate out to other scale gear at other locations. Mix and match. It doesn't have to be identical hardware at that remote site to make that happen. And if I ever want to utilize cloud offerings, we have a unique partnership with Google to be able to replicate directly into Google's cloud platform there. This is a unique partnership that allows you to utilize their hardware stack in the cloud-based environment, but I'm still utilizing that exact same interface for my Scale HC3 environment there. When it comes to deployments, again, you can start with something as simple as a single node. Maybe I've got a remote office, branch office. It doesn't require much, a print server, file server, something like that. But as my needs grow, I can always stack more onto it, make it a full high available cluster there. Distributed enterprises, we're seeing a lot of that. A lot of larger organizations are breaking up their traditional data center and kind of moving them out and about. So that way, even their locality isn't a single point of failure. These work great also as a backup target if I want to use that replication to an off-site location. As I mentioned earlier, Google Cloud, that is an offering that we have there as well. It's mentioned something about the HC3 private cloud, but basically that's your on-prem device. You'll notice when I bring up the interface and I'm demoing with it, it's going to look and feel like your own private cloud environment. I'm not worried about different aspects of the hardware, but set that up to replicate to a Google Cloud instance there. Again, pay as you go. It can elastically burst when I need to boot systems up, so that way I've got a lower cost during normal times, but in the event of a DR and I need to burst and expand out to run my workloads, then it's a different price structure at that point in time there. Some of the advantages that we have, I mentioned some of these in the previous slides here, but this is designed to be like those Lego blocks. Start with something small, grow as you need to, turn it into an operational cost instead of trying to buy 5 to 7 years worth of hardware right out of the gate. The intelligence, the machine learning that's in there, that's always updated to be more self-healing as updates are progressed through there. The idea is to take the IT management out of it, let it do its own thing, so that way you have more time as the admin for other projects in there. The hypervisor, that's baked into each and every piece of the hardware there, so there's no software to install. It's basically given an IP address, and I'm ready to go and install virtual machines there. Our support, that's here in-house at our headquarters. We only offer one level of support, and it's 24/7 every day of the year, and it's next business day on that replacement hardware. One thing you will find too is I don't have to be a 3-time certified storage admin. I don't have to be a VMware V-expert to be really sharp and run this infrastructure there. You'll see that a lot of that intelligence that's baked in, again, is going to be cruise control for virtualization there. So with that, let me jump out of the slides and actually see what the heck we're talking about here. So here is a 3-node cluster that I have sitting in my lab environment. It's all managed with a web browser. It's HTML5, so I don't have to worry about having specific, specific add-ons, anything like that. No Java. But to manage it, you type the IP address of any one of the nodes that you have in the environment. You don't need to have an isolated vCenter server, a management system, anything like that. We see that as a potential point of failure. So this is a distributed management model. Log into any one of the nodes, and I have that centralized management here. Up top, heads-up display shows me in real time what's going on with my cluster. The first 3 gauges, that's all about my resources, CPU, RAM, disk capacity. They'll bounce around like the tachometer of a car. They'll even start changing colors, yellows, oranges, reds, to let me know when I'm approaching or I've actually reached that failover capacity, that N+1. With other vendors, it's hard to tell, hey, did I kind of write a check that I might not be able to cash here if some hardware goes offline? You can always click into the gauges, get more information. Hey, is dedupe doing anything for me? Any more of that detailed information that you need to know. The other 2 gauges, that's about performance. Right now it's doing a little over 6,000 IOPS worth of workload here. So you can really put the pedal to the metal on these guys. Sometimes I have it sitting at about 18,000 IOPS. So there is performance baked right into here. I don't have to worry about tiering different levels to achieve that. Any issues will show up here in the corner, plus the product will send you emails as well, so I don't have to sit in the user interface. This represents those physical nodes that I have sitting back in the rack. This is a 3-node environment. If I look on this tab, this is a single node environment. It's just 1 rectangle instead of 3, but the management is still exactly the same. This is showing me how I'm utilizing the RAM on my host. This is showing the disk layout. Now, the number of disks, the size of disk, that's all dependent on the model that you choose, what's kind of required for your needs there. A lot of people, after probably about a couple weeks of utilizing it, they don't even care to see the host anymore. They're, hey, you know what, I don't need to manage my hardware. They'll minimize that. And then they'll focus on the virtual machines. So categorize your virtual machines down here like I have, maybe by person, maybe by departments, whatever you need. Each one of these tiles that you see is a virtual machine that I have in my environment here. All the tools that I need, I can come in here and say, hey, let's give this guy 12 gigs of RAM, update. You'll find that it takes about 3 clicks to do any task that you want to do, whether it's build new VMs, whether it's set it to auto protect, whether it's set it up for disaster recovery there. So one thing I'll do to kind of highlight some of the unique features we have is I'll go ahead and build a virtual machine and hit some of those feature points there, so you get an idea of what's day in the life of this administrative like here. So to add a virtual machine, I just hit the plus sign right here. I will call this one Vista IT is the name of my server. What kind of description do I want? And we'll say this is a customer database that I have. Anything I want to be searchable and filtered. Tags, that's these blue categories over here. Type a new one, or I'll hit the drop down and I'll just use my name as the tag. Is it Windows? Is it Linux? It slipstreams drivers in for me if I need to. We'll give it 2 CPUs. We'll give this guy 18 gigs of RAM. We'll give it an 80 gig C drive. We'll give it maybe 300 gigs for a database. And you know what? Maybe I'll make it a archive drive as well too. Put a 3 terabyte drive on there for that. I'm going to make it server 2016, and then I hit the create button. That was the long way to build a virtual machine. You can do templates. It's 2 clicks and about 10 seconds and I'm done. But this was the long way here. If I need to fine tune this system, I can always come into the gear wheel, maybe adjust drives, maybe I want a specific network. Maybe 112 is the VLAN that I want this system to be on. I can adjust that as well. If I'm happy with it, hit the power button. Let me expand the host here. So compared to other products out there, like many people are used to VMware, one, I didn't go chase down where I have 3 terabytes of capacity. I don't need to. The product's going to find that location for me. It's going to mirror it and stripe it, make sure it's highly available. I can survive multiple drive failures in this environment. Drive 0 on node 1 dies. Oh, well, I don't care. Drive 2 dies. Don't care. Drive 1 on this dies. Don't care. We have automatic mirroring of missing data blocks, so it's not going to do blank space and all, but just those critical blocks. So even before I swap out bad drives, I am highly available again before I even replace that drive. That's why we can survive 3 or 4 drives dying within the cluster and still no data loss. Here's my virtual machine. It chose node number 2 based on performance metrics, based on requirements, and said this is the best place for my Vista server to run. There's a console button here. It launches a new tab, and we can see that it's launching that Windows installer disk that I told it to mount and run from there. So it's installing Windows for us. Now, if for an instance I don't want it on node 2, I'd rather it be on node 3, you can always live migrate those systems, hit the move button, click over here on node 3, and down in the bottom it says, sure thing, Frank, we'll shimmy that system right over there. No interruption. Rarely does it ever even drop a ping during this. Best of all, it's typically 15 seconds or less. Doesn't matter how large that virtual machine is. One thing I'll highlight here too is every feature piece that I show you here is always included with the product. It's not that we have the starter edition, the Enterprise Plus. So know that every model that you get always comes with all these features that I'm highlighting here. One of my favorite features is our snapshots. It is night and day different compared to everybody else in the industry. And a lot of that has to do with we've created the storage platform underneath this for virtualization. It wasn't an afterthought. It was, hey, let's create what we call Scribe, built for virtualization. And because of that, we got rid of a lot of the limits that you typically see with things like VMware, with Hyper-V, when it comes to snapshots. One of those limits is if I take a snapshot and I forget about it and it's sitting around too long, it creates a Delta file, gets very big, chews up lots of disk space. That's not an issue here. We're using pointer records and metadata, so now I can keep systems or snapshots around for a long time if I want to. The other limit that you typically run across is if you take too many snapshots on a single VM, kind of like what I'm doing right here. You really tank the performance on that virtual machine. Not a problem here. In fact, if you want to, you can take over 5,000 snapshots on each and every virtual machine if you want to. I haven't found a reason why yet, but you can if you want to. Best all is how you get to utilize these snapshots. They're not a rewind button. So this is our all critical Vista customer database. I want to apply Service Pack 2 to this. Maybe I got to do it after hours, keep my fingers crossed, make sure it doesn't mess anything up. Man, I sure would like to test that before I do it on the real production system. Well, come into my snapshots. I took 6 of them while we were talking. I can pick any point in time and say, hey, you know what, create an exact copy of that database with all its data exactly like it was right there. 3 clicks. I wait less than 10 seconds, and I have a full-blown copy of that system from any point in time that I choose. Now I can isolate it by disconnecting the network adapter, or maybe I've got a separate VLAN set up for my lab environment. Now I can test this away in normal business hours, troubleshoot stuff, you know, perfect sandboxing available within the product at the drop of a hat. I can take this even further by setting up schedules. You know, have it automatically do snapshots for me. So here's a schedule I built that does it every 15 minutes and deletes it after 6 hours, you know, on the top of the hour, in the evening, on the first of the week, and on the first of the month. So, hey, if that looks great, I can come in here and say, hey, let's select a schedule. I want you to do that critical systems routine, and then now every 15 minutes that system is going to start taking a snapshot. I can then take that even further and say, hey, I want these copies off-site somewhere. Come into the environment here. There's a section that says remote clusters. Here is where I can link all my different locations together. This is that Google Cloud instance I mentioned earlier. In fact, if I come up to this tab on my browser, this is Google's Cloud. It looks no different than what I would normally be in if I was just on-prem scale device, except for, hey, now I don't have any hardware. So link these different sites together. Once I have them, I can say, you know what, this is pretty important. I'm going to take this, and I'm going to send it to a single node that I have across town there. Again, 3 clicks, no scripting, no third-party tools, no additional licensing. Now I've got a copy of this server every 15 minutes sitting at a remote facility in case I lose power, or worse here, at my main production location here. Another aspect that I really like related to the storage is how you can utilize the SSDs within the models here. So we have all spinning disk models, all SSD models, or hybrid models like this. You can use this as a tiered storage layer. It doesn't have to be sitting around and used as a write cache device here. So if I come into my virtual machine that we built here and say, hey, this 3 terabyte drive, let's look at this drive. This is just cold archive data. You know, by default, anytime I create a new VM or a new disk, it sets it as a 4 on this heat priority. This is heat mapping based on data block usage of that disk. And what it'll do is identify the hot blocks and set those on the SSD so the reads and writes occur at that SSD speed, but it puts the rest of the disk on spinning. But I could say, you know what, I don't care that this guy is on SSD, so turn it down to a minimum to where, hey, maybe the most active 1 gig touches it. Or in this case, I'm going to go to a 0. I'm going to make this disk pure spinner disk. My OS drive, this is a pretty critical system. I want this to be a little bit faster, or I want it to be a lot faster. Go to an 8. That's absurd level right there. A lot more of my reads and writes will occur on the SSD. 300 gig though, this is where all the critical stuff is. I want this thing to be the fastest thing that we've got. Go to a 10. There's ludicrous speed if you want to. But our engineers just said, you know what, 10's not enough, so they made them go to 11. When you do that, I have now pinned this drive to be pure SSD. So within one VM, pure spinning disk, pure SSD disk, and one disk that's an ever-changing combination between those tiers there. Best of all, didn't log into a storage layer. I didn't read a best practices guide that's 20 pages long. Very intuitive to understand how to tune each and every virtual machine within the product here. One more aspect that I like is system updates. Now, this is very boring to look at because I can look in the corner and see, hey, I'm running the latest version. But since we are that entire stack, you got to think of the storage layer, the server hardware, the firmware involved with that, the hypervisor, the management set, the features. All of that is done in this one shop. If there's an update available, it'll show up in here. It'll be bullet pointed out, tell me exactly what's in that update. From there, I would click a update button, and it's going to ask you, are you sure you want to do this? You say okay, and that's it. Walk away from it. 2 mouse clicks, and everything from the BIOS of the hardware up to the virtual machine will get updated with no downtime. It'll come to node 1 and evacuate all the virtual machines and balance them across the rest of the nodes in the cluster. Once this node is empty, it'll do all that patching, reboot if it requires it, comes back online. These systems, their state machines, will do a health assessment to make sure that system is fully functional. Once it passes, it goes to node 2, then it goes to node 3. So you don't babysit this to keep it fully up to date. So that's a big time saver right there.